Hello, I'm Mr. Rafael Jimenez, grade 9 teacher from Aries, and this is the Division, Remediation, and Enhancement of Aptitude in Mathematics through e-learning, or Project eDreams. Our topic for today is all about finding the roots of polynomial equation from grade 10, quarter 1, week 8. I will discuss first what is roots in algebra. In this example, this is the graph of polynomial function. This graph touches the x-axis 3 times, and that is -3, +2, and +5. And these points of intersection called the roots, zeros, and solution of polynomial function. Again, the term roots, zeros, and solutions of polynomial function are virtually the points of intersection of the graph of the polynomial to the x-axis. Next is the theorem about polynomial function. The first theorem is fundamental theorem of algebra. Every polynomial equation p of x of degree n has at least one complex root. Second is the number of real roots. A polynomial equation cannot have more real roots than its degree. Okay, in this theorem, for example, we have a cubic polynomial function. Since in cubic, the degree is 3. Therefore, the highest or the utmost number of roots that we have is 3. The third theorem is rational root theorem. If a polynomial equation, this is the form of polynomial equation, has integer coefficient, then every rational root of polynomial equation has the form of p over q, where p and q have no common factors other than 1, and where p is an integer factor of the constant term a sub 0, and q is the integer factor of the leading coefficient a sub n. This time, we are now ready to find the roots of polynomial equation. The following procedure will guide us to find 4 roots. Okay, step number 1. Use the rational roots theorem to list all the possible rational roots of polynomial equation. Number 2. Use synthetic division to evaluate each possible roots p over q list in step 1. If the remainder is equal to 0, then p over q is a root of polynomial equation. Repeat synthetic division until the remaining quotient is quadratic polynomial. Then use factoring or quadratic formula to find the other roots. Third step, list down the roots of polynomial equation. Okay, using these steps, let's have an example. Okay, example number 1. The function of x, or the p of x, is equal to x cubed minus 2x squared minus x plus 2. Then, step 1, list all the possible roots of the equation using the rational roots theorem. Okay, first, list the factors of the constant term. The constant term is this, the positive 2. Then the factors of 2 is 1 and 2. Since we are in the algebra, we need to consider the positive number and the negative number, which is positive negative 1 and positive negative 2. Then, list the factors of leading coefficient. The leading coefficient is here, the invisible one here. Therefore, the factors of 1 is 1, which is positive negative 1. And then, list the possible rational roots, P over Q. We're going to divide all the factors of constant term to all the factors of the leading coefficient. And positive negative 1 divided by positive negative 1 is positive negative 1. And then, positive negative 2 divided by positive negative 1, that is positive negative 2. And then, we have all the possible rational roots, which is positive negative 1 and positive negative 2. Step 2. Using the possible roots, divide the polynomial through synthetic division and look for the zero remainder. Okay, in synthetic division, we need to get all the constant or the coefficient of this function. We have 1, negative 2, negative 1, and positive 2. And then, we're going to use the easiest one, which is positive 1. This is the possible roots that we have, positive 1. And then, using the synthetic division, the first thing to do is to bring down the leading coefficient. And then multiply. 1 times 1 is 1. And then add. Negative 2 plus 1 is negative 1. Then multiply again. Negative 1 times 1 is negative 1. And then add again. Negative 1 plus negative 1 is negative 2. Then multiply. Negative 2 times 1 is negative 2. Then add. Positive 2 plus negative 2 is 0. Now, as you can see, the remainder is equal to 0. Therefore, positive 1 is a 0 of this polynomial function. And then, as you can notice, our quotient is polynomial or quadratic polynomial. Therefore, we can use factoring or quadratic formula to solve for the other roots. We can write this quotient as x squared minus x minus 2 is equal to 0. Since this quadratic equation or quadratic polynomial is factorable, therefore, I'm going to use factoring. Now, in factoring, I need to get the factors of 2, which is 2 and 1, and then place here. Now, we're going to check the factors. Negative 2 times 1 is negative 2, and then negative 2 plus 1 is negative 1. Therefore, the factors is correct. And then, using the zero product property, we're going to equate the factors into zeros. Negative x minus 2 is equal to 0 and x plus 1 is equal to 0. And then, using the addition property of equality, we're going to get the additive inverse of the constant. The additive inverse of negative 2 is positive 2. And the additive inverse of positive 1 is negative 1. Therefore, the zeros of polynomial functions are 1, 2, and negative 1. This is the first zeros that we get, and this is the other factors, the other zeros, which is 1, 2, and negative 1 are the zeros of our polynomial function. That is example number 1. Now, let's have example number 2. Example number 2, p of x is equal to 4 to x raised to 4 minus 3x cubed minus 4x squared plus 12x. Now, as you can notice, we don't have a constant term here, but all of the terms have x. Therefore, I can factor out x from it. And then, the p of x is equal to x times the quantity of x cubed minus 3x squared minus 4x plus 12. Then, using the zero product property, now I can get the first zero that I have, which is x is equal to 0. Therefore, 0 is the first zero of my polynomial function, or 0 is the first solution that I have. Now, using the step, list all the possible roots of the equation using the rational roots theorem. Now, we're going to use the steps here, the second factor that we have. Now, list all the list factors of the constant term. Since the constant term is 12, we're going to list the factors, which is positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and positive negative 12. And the factors in the leading coefficient, which is the invisible one. That is positive negative 1. And then we're going to divide P over Q, or we're going to divide all of the factors of the constant to the factors of the leading coefficient. Then, after dividing, therefore, the possible rational roots are positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and positive negative 12. Now, step number 2. Using these possible roots, divide the polynomial through synthetic division and look for a zero remainder. Now, in this factor, the coefficient is positive 1, negative 3, negative 4, and positive 12. We're going to write all of that. And then, let's try the easiest one, which is positive 1. Now, using the synthetic division, bring down positive 1. And then multiply. 1 times 1 is 1. And then add. Negative 3 plus 1 is negative 2. And then multiply again. 1 times negative 2 is negative 2. And then add. Negative 4 plus 2 is negative 6. Then multiply again. Negative 6 times 1 is negative 6. Then add. Positive 12 plus negative 6 is positive 6. Now, as you can notice, the remainder is not equal to 0. Therefore, positive 1 is not a 0 for our function. Or, positive 1 is not solution of our function. And then, let's try negative 1. Since positive 1 is not a solution, let's try the negative 1. Then, the same process, bring down 1, multiply, negative 1 times 1 is negative 1, then add. Negative 3 plus negative 1 is negative 4. Then multiply. Negative 1 times negative 4 is positive 4. Negative 4 plus 4 is 0. And then 0 times negative 1 is 0. Then add. 12 plus 0 is 12. Now, again, the remainder is not 0. Therefore, negative 1 is not 0 of our polynomial function or polynomial equation. Okay, now, since positive and negative 1 is not 0 of our function, therefore, let's try positive 2. And then, divide. Bring down positive 1, then multiply. 2 times 1 is 2. Then add negative 3 plus 2 is negative 1. Then multiply. Negative 1 times 2 is negative 2. Then add negative 4 plus negative 2 is negative 6. Negative 6 times 2 is negative 12. Then add positive 12 plus negative 12 is 0. Now, we have a 0 remainder. Therefore, 2 is a 0 of our function. Now, we have two roots. Since x is equal to 0 and 2 is equal to 0. And then, the degree that we have is 4, or we have a fourth degree. Therefore, the utmost number of roots that we have is 4 only. Since we have 2, we are looking for the last 2 of our zeros. Now, the quotient of our synthetic division is in quadratic polynomial. Therefore, we can use factoring or quadratic formula to solve for the other 2 roots. Then, I can write this quotient as x squared minus x minus 6 is equal to 0. And then, by factoring, the answer is the quantity of x minus 3 times the x plus 2 is equal to 0. And then, using the zero product property, I'm going to equate 0 the two factors that I have. I have x minus 3 is equal to 0 and x plus 2 is equal to 0. Then, using the addition property of equality, I'm going to get the additive inverse of 3, a negative 3, that is positive 3. The additive inverse of negative 3 is positive 3, and the additive inverse of positive 2 is negative 2. Therefore, okay, step 3, list down the roots of polynomial equation. Now, therefore, the roots of polynomial equation or the function of x are 0, 2, negative 2, and 3. This is the first root that we have. Then, this is the second root. By factoring, we get the positive 3 and negative 2. Then that's all the roots of our polynomial equation. Okay, now let's have our last example, which is example number 3. Okay, example number 3. Okay, the p of x is equal to x cubed minus 4x squared minus 7x minus 4. Now, step 1, list all the possible roots of the equation using the rational roots theorem. Then, list the factors of the constant term. The constant term is negative 4. Then, the factors of negative 4 is positive negative 1, positive negative 2, and positive negative 4. And then, we're going to list all the factors of the leading coefficient. The leading coefficient is invisible 1 here. Therefore, the factors is positive negative 1. Then, we're going to divide P over Q. Okay, by dividing all of this, the answer is positive negative 1, positive negative 2, and positive negative 4. And then, step number 2. Using these possible roots, divide the polynomial through synthetic division and look for the zero remainder. Then, getting the coefficient of our polynomial function, that is positive 1, negative 4, positive 7, and negative 4. And then, let's try the positive 1 here. Okay, the first thing to do is to bring down positive 1. That is 1. We're going to multiply 1 times 1. That is 1. Then add negative 3 plus 1 is negative 3. And then negative 3 times 1 is negative 3. Then add positive 7 plus negative 3 is 4. Then multiply. 4 times negative 1 is 4 times positive 1 is positive 4. And then add negative 4 plus 4 is equal to 0. Wow. The remainder is equal to 0. Since the remainder is equal to 0, positive 1 is a 0 of our quadratic polynomial function. Now, since the quotient is in the quadratic polynomial, therefore, we can use factoring or quadratic formula to solve for the other roots. Now, in this form, x squared minus 3x plus 4 is equal to 0. This is not a factorable. X squared plus 3x plus 4 is equal to 0 is not factorable. Therefore, I'm going to use the quadratic formula. X is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. And then, we're going to get the value of a, b, c of our quadratic equation. That is, a is the invisible one here. negative 3 is the b, and the constant term is the c. And then by substitution, we're going to substitute or plug in the value of a, b, c to the formula. And it will look like this. And then simplify. Since negative times negative 3 is positive 3, and then negative 3 squared, that is negative 3, times negative 3, that is positive 9. Negative 4 plus 1, I mean, negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. And then 2 times 1 is 2. Then, simplify again. That is 9 minus 16 is negative 7. Since square root of negative number is imaginary number, so we don't need to simplify that. Therefore, we're going to list all the roots of polynomial equation. Okay, therefore the roots of the polynomial equation are 1 and 3 plus minus square root of negative 7 over 2. Again, the zeros of the polynomial function are 1 and 3 plus minus square root of negative 7 all over 2. And that ends my episode today. I hope you had an amazing time with me, your math learning buddy, Sir Rafaelito Jimenez from Aries. Always keep safe. And this is Project Dreams.